So we are going to learn about the glaciers because we mentioned them many times, and in fact I have podcasts already in the other sections, but I have to plan for kids who will jump directly into this section of the course, and you cannot have part of the course covered here since this is a book called What is Climate Change, and then I have to include all of the parts even if some of it is repetition. And it doesn't matter if you listen again and the concepts get re-emphasized and become solidified in your head, which is good thing, right? It's like studying in the class, listening and then studying again for homework and studying again for the final and so on and so forth. We already mentioned, maybe you already know, that glaciers are different than ice in many ways, mostly because glaciers only grow on land. It cannot grow on the ocean. On the ocean you can freeze water and have sea ice, and you already know that ice tends to be brittle, which if you go to the refrigerator, take out some ice cubes from the fridge and you hit it with a hammer, do it carefully with some adult supervision if you're not old enough, and see it breaks into pieces like glass. Whereas glacier, which forms on land because it needs snow to fall, and it needs more snow to fall on top and more snow to fall on top. And how does that happen? You are looking at a peak here which is cold, it's high enough, it's high latitude, so whatever, and snow falls in a fall and winter of one year, and it doesn't melt in the summer of the following year because it's still too cold, and more snow falls next fall and winter, and snow keeps on falling, and as the weight of the snow keeps pressing on the snow below, it begins to get compressed and freeze into more solid form than snow, which can be very powdery, right? So that glacier that forms by compressed snow is different than ice because it's not so brittle. It can flow like molasses. You can already see that peak is here, and it seems to have flowed down, and it will flow down here and maybe eventually reach the ocean or form a lake, as we'll see in a minute, and so on and so forth. And in the climate context, these are very critical because they do a couple of things. One is that you're moving all this water from the ocean or the lakes, you are evaporating them, you're moving the clouds, you're snowing on top of the mountains, and you're locking up that water because once you move it and fall snow on the mountain and it doesn't melt and come back, then it's locked up. So you are slowly going to reduce the sea level if you build more and more and more glacier. Okay, that's one thing, which also means when the glaciers melt, as we are doing during global warming, then that water is getting released back to the oceans, which means the sea level is going to rise back again, right? So this is one of the major consequences of global warming, as we'll see later, that the sea level rises because of the glacier melt and the water being released back to the original place, and also because with global warming the oceans themselves are warming, and warm water has higher volume, larger volume, so it expands. And we are also changing the salt content in the ocean water because we are raining less or more, and we are flowing this glacier water, which is fresh water, into the ocean and so on. So the density of the seawater, right, density is mass divided by volume. So when you change the density, you are, let's say, adding some mass because new water is coming in, but you're changing volume because of temperature, and adding water as well as changing salinity because the density of the water in a very complicated way depends on temperature and salt in the water, or salinity in the water. So all these things matter, but glaciers are doing another thing. What are they doing? You look at it, it looks bright white. What does it mean? You already learned about albedo, reflection of the sunlight, which means if there is glacier, it is reflecting the sunlight, which means the energy is being lost back to space, which will make the earth cooler, of course, because you're getting less energy. But under global warming, it can also mean less warming because you are trapping the outgoing thermal energy or the long wave energy or the infrared energy and so on and so forth. Infrared wavelength, but anyway, you can remember it as infrared energy in the infrared band, however you want to remember it. So the albedo will also change if you melt the glacier. This is a dark surface which is not going to reflect sunlight, it is going to absorb the sunlight, so it's going to make the climate warmer because it's going to keep more of the sunlight, which means if you melt some glacier, you reduce the albedo, you absorb more energy, you make it warmer, which means you melt more glacier, so you decrease the albedo again, you keep more energy, and you are in a vicious circle or a positive feedback loop of the ice albedo feedback. We talked about it in detail in the other sections. You can go back and listen as well. And we have some diagrams there as well to discuss how the ice albedo feedback is making the Arctic warmer than rest of the world in many places, as we'll see. Okay, so those are the glaciers, and we will see where all the glaciers are. This is a nice map from this antarcticglaciers.org, which is showing glaciers on Greenland, of course, and Antarctica, of course, and the Himalayas, of course, and some mountains here, Mount Rainier and the Andes mountains, and some coastlines here. There are some areas here that are cold enough to hold glaciers, like the Columbia Glacier, which is a fantastic place to visit and hike, and there are glaciers here. So as long as it's very cold because of the altitude or because of the latitude, here it's cold because of the latitude, altitude, how high the Himalayan mountains are, and here it's cold because of the latitude, and so on. So if the snow that falls in one year doesn't melt on land, because on the ocean you cannot do this, ocean freezes, forms sea ice, but it cannot keep accumulating snow and compress, right? Snow, if falls on the ocean, it'll just mix with the water, melt away, or so on and so forth. So sea ice is very different than glacier. Glacier is only on land. When glacier gets very big, we call it ice sheets, and so on and so forth. So we'll come back and learn more about the glaciers in the next podcast. So we'll look at the changes in the cryosphere, since we are in the section called What is Climate Change? By the way, look at the titles of the podcast. I say, what are glaciers? Taatha. What is Taatha? If you are Indian, maybe South Indian, you probably know what this means. Just to be a little bit funny, I'm putting these things in the title to say grandpa, grampy, tata, aja, because I'm saying you can think of me as your grandfather if you're young enough, or you can think of me as an uncle and ask questions, and of course you can think of me as a teacher as well. But anyway, let's just have some fun. Okay, so you can send comments, questions, and of course you can always ask questions of your brother, sister, mom, dad, grandpa, grampy, neighbor, teacher, and so on, friends as well. Okay, see you in the next podcast. More on glaciers.